Hello, and welcome to MVAO301, Using Total Object Manager or TOM. This is Part 4. MVAO 301 is the seventh in an 8-part series of courses covering MainView AutoOPERATOR. In this session, we'll discuss managing objects and sets using the TOM interface. Managing objects in TOM typically take two forms of commands. We have primary commands that you issue on the command line, and then we have line commands which you would issue to the left of the object entries. If you want to see which commands are available to a specific view, you can type the show act command in the 3270 interface. And then Tom is going to ask you, do you want to see the commands available for views with objects or views with secondary records such as dependencies or calendars? In this case, we'll select views of objects and Tom will give us a list of the available commands. In the MainView Explorer GUI interface, we can type show act, but that command isn't supported as shown here. Instead, what we'll do is we'll right-click on an object and we'll select line action, and then we'll see a list of the various actions that are available to be taken against the object in this display. Let's take a look at some of the primary commands that Tom supplies. The first is the add command, and the add command is used to add a new object definition to the definition base. Active all unconditionally places all objects that have been suspended into a control mode of active. And that's to say that Tom will begin to manage their status according to what he sees as dependencies and calendars. Then there's a suspend all command, which is the opposite of active all. It unconditionally places all the objects into a suspend mode, where Tom will only monitor the status of the object, but he will not take any actions to start or stop them. Additional commands include tag all, which allows you to tag different objects in a list so that you can deploy them as a group. And the reason why you would want to deploy things is if you build a model system on one LPAR and then you want to take that and implement it on another LPAR, you can use a combination of the tag and deploy commands. Another handy command that you will use in the 3270 interface is the OPR or operator command. To use this command, you'd simply type in OPR next to the object that you wish to take an action against. And Tom will pop up a display like this. So here we see the most common commands that operators will want to issue, and you can simply go down and select them with an S. Issuing line commands in the MainView Explorer GUI interface is a little bit different than doing it in the 3270. If you want to take an action against an object, you'll right-click on it, select line action, and then you'll be presented with a list of different actions that you can take against the object. And it will explode it up a little bit so you can see it a little bit better there. So you have all the typical actions that you'd want to take, such as start, stop, lock, unlock, move, bounce, reset, so on and so forth. Additional line commands that you can use against objects in TOM are edit, so that you can get the edit modify dialog going. You can change your definitions for your objects, modify descriptions. We have a repeat option that allows you to take a copy of an object definition and build a new one, so you could use it as a quick model. You can delete an object definition from the TOM registry using the delete command. And you can do a browse real-time or BT command to see a detailed view of all the object's attributes. I've already mentioned the operator or OPR command, and that pops up a quick list of the most common actions that an operator would take against objects. There's also a reset command or RES, and that lets you reset counters and various control modes for the object in the TOM definition. There's a bounce command, which can be used as BOU or abbreviated O, and what that does is it issues a stop and then a start for the selected object. There's a move or M command that allows you to move an object between LPARs that are defined to Tom. There's a stop command or P to stop an object. And of course, there's a start command or STA to start an object. The lock command, or L, places an object into a lock status. And what a lock status is it essentially stops the object and says, keep this object down unless I explicitly unlock them or you IPL the system. And after an IPL, then he'll go back into his normal status and Tom will begin managing him. Now, unlike the lock command, the block command persists across IPLs. So if you issue a block against an object, Tom will shut him down and he will keep him down until you explicitly use the unblock command. And that, again, will persist across IPLs. So if you're shutting something down, you don't think you're going to run it, or maybe you only run it occasionally, blocked is probably the way you want to go. If you wish to suspend an object so you don't want Tom to manage it anymore, you can use the suspend or U line command. To reverse a suspend or unsuspend an object, you can use the A line command. Don't use change status. We're just going to kind of gloss that over. Additional line commands include the tag command, which is a way to aggregate different objects to do a single command against all of them, such as a deploy to a different system. The propagate or J command takes the changes that were made in layer objects and then propagates it to objects that were generated from the layer. QL or query layer displays the information that's associated with layer sets and objects that are generated by the attach command. You can use the S command or select to display a detailed view of the object that you've selected. The information that is displayed is going to vary dependent upon the type of object you're displaying. Most commonly, you'll do the select for objects and you'll get a list of all the object attributes. Tom also supplies a dependency chart that's really pretty useful. It provides a hierarchical representation of your dependencies, and the user can see the object relationships as well as their statuses in the form of a chart. Now, TDEP-CH, or the dependency chart, is only available in the MainView Explorer GUI. And here's an example of the dependency chart. So you can see the way that things are mapped out. We build the hierarchy of how things are related to each other. And then you'll see the items in red are objects that are currently not active, whereas the ones in green are active. Now you can also take actions from this. If we right-click on an object and then select line action, Tom will present us with a list of the various actions that are available to take against the object. So we can do a lot of things from this dependency chart. It's not just eye candy to look at. Now I'd like to take a few minutes to discuss some of the statuses that Tom shows for objects. The first is active, which is fairly straightforward, and it means that the object is currently running and that Tom is maintaining its status. Active bounce indicates that Tom is currently performing a bounce of the object. Active error means that the object was stopped outside of the control of Tom, and Tom doesn't understand what state he's in. Active hold means an object has been stopped with Tom using the hold option. Active hold means that the object has been stopped with the stop hold command. It also indicates that the pre and post stop execs for the object were not scheduled. Dependents of objects are not affected by this status. They will still see this object as being active, but this is a sub-status, think of it as, that gives you some indication of how the object was processed at startup. Active no auto means that a bounce was issued, but no automation is being performed to support that. Active SD indicates that the object was stopped outside of Tom, but Tom is currently restarting the object. If you see active appended, that means that Tom has seen the abnormal termination event that was defined in the object definition and that the object has issued that message or met that criteria. Common failure statuses include failure appended, which means that Tom saw the abnormal termination event for an object and it came down. If you see failure AO link, that means that Tom is not able to communicate with the MainView AutoOPERATOR address space. Failure command init means that we're having a problem with the start command or the exec related to the start command. And failure command term indicates the same thing for a stop command or the exec related to the stop command. Failure command count means that your start command has been issued its maximum number of times as defined in the object definition. Failure confirm indicates that the user replied no to a WTOR that gets issued when you've selected the verify start or the verify stop options in the object definition. And failure init term is kind of a catch-all that Tom just does not know what's going on with that object. Hopefully you don't see very many of those. Failure pre-start indicates that the pre-start exec related to an object issued a non-zero return code. Similarly, failure pre-stop indicates that a non-zero return code was received from a pre-stop exec in the object definition. If you see failure-property, that indicates you've got something just bad in your definition. You're missing a property that needs to be there. In this situation, you should go back and carefully review your object definition. Probably the two most common statuses that you're going to see that are problematic are failure recognition, which indicates an error during the start for an object, and failure rec term, which indicates an error for the stop action for an object. So when you see failure recognition, if the object actually starts, the problem is likely going to be with your start validation event. Whereas if the object does not start, then you probably need to review the start command to ensure that it's specified correctly. And you have the same type of thing for your failure recognition, except we're talking about the stop command and the stop validation message. A lock status indicates that the object is down and cannot be restarted on the current system until we IPL. This can happen in one of two ways. Either the user has used the Tom move function to move the object to another LPAR, or the user has gone in and issued an explicit lock command against the object. If you see a locked error status, that means that someone has issued a lock command against the object, but the object is still running. Scheduled status means that Tom has issued a command either to start or stop the object. If you see scheduled lock, it means that an object is being stopped, and then when he completes stopping, he'll go into a lock state. If you see scheduled block, same thing as locked. Someone's issued a block command. Once the object comes down, then Tom will change the status to blocked. The stop status is fairly straightforward, just means Tom has stopped the object successfully. If you see stopped external, that means that someone outside of Tom stopped the object. And if you see a stopping status, that means Tom is in the process of stopping the actual object. Like stopping, starting indicates that Tom has issued the start command, but he's waiting for the validation event to occur. And then wait start is indicated for restart only objects that are started outside of Tom, but Tom will manage them once they're active. And common started tests that are managed this way are LLA, DLF, VLF. A pending status indicates that Tom is in the process of moving an object and he can't start it on another system until he stops it on the original system. Unknown is kind of a catch-all. If you have an object that's being reset with a line command, then he can go into an unknown status. If he's defined for a system, but you can't get to that system, he'll be in an unknown status. Or if you issue a reset for an object that's on another LPAR that's not connected to the current TOM you're in, you'll see an unknown status. So kind of a lot of reasons you can get into unknown, but it's rare that you're going to see that. This concludes MVAO 301 Part 4. Thank you.